Okay, back with some quick math. This is question 2. It is functions, in fact, inverse functions. Like the video, subscribe to the channel, share the content, help the channel to grow. Let's get straight into this. 2.1. Write down the equation of, okay, I see you can't see it. There we go. Of p to the power of minus 1. So this is the inverse function of p in the form y is equal. Let's start with writing down p quickly. So p of x is equal to 1 over 4 to the power of x. This is the same, or we could think of this as y, right? Our function value, we can think of it as y. So we could say y is equal to 1 over 4, all of this to the power of x, and this is still just p, okay? But if I wanted, which is what they ask us in this question, the inverse, then we need to take this one and swap x and y. So whatever this is and this, I need to change places. Okay, great. That's easy enough. So I'm going to have x is equal to 1 over 4 to the power of y. And now we need y to become our subject, okay? So short way that I teach you is if this is the subject or this is the exponent becomes the subject. The base becomes the base of the log, and your subject goes into your log, right? That's the short way. I'm not gonna spend time in this video on the long way. Maybe I can do that in a different video, but okay. Main thing is what we did is we from p to the inverse of p, swap x and y, and then make y the subject. Okay, so now we have this exponent, this logarithmic function. So that was all that you had to do at 2.1. At 2.2, they ask us to sketch both of these. Sketch P, which is this one, and so let me just write this again here because I see I wrote all over it and now it looks cluttered. So I need to sketch this one and I need to sketch this one. Okay, I'm going to draw very rough sketches in order to do that. Okay, let's just read again. Clearly indicate all intercepts with the axes as well as the axis of symmetry. Okay, make sure you read the question. So many of you didn't draw the axis of symmetry for me, and I'm sure it's simply because you didn't read the question. All right, so let's get into drawing this. Okay, I'm going to draw very rough sketches, okay? You were provided with graph paper. I'm just going to draw a random Cartesian plane for myself here. All right. So what do I know? I'm going to start by drawing p, which is a exponential function. So let's just go look back here. This is the one that I'm going to start with. I can see it's exponential. I can also see that my b value, right? So we should know exponential functions general form, y equals a, b to the power of x. Maybe there's a q there, maybe there's a minus p there, right? But this is my general form. And if this value is 1, then our positive, then I know it's going to be on top, okay? So this is a positive a value, so I know my function is going to exist in the positive quadrant. So that's on top of the line. And my b is 1 over 4. It's a fraction. It's not a fraction, but it's between 0 and 1. So I know this function decreases, okay? And then q is 0 and p is also 0, so it didn't shift up or down, it didn't shift left and right. What I do know is it's positive, so it's on top, and I know that it starts here and it decreases. How do I know this? Make sure that that looks like it's going close to the x-axis, right? How do I know this? Because my b is in between 0 and 1, and my a is positive. This coordinate, right, provided it doesn't go up or down or left and right, this coordinate is always going to be 0 and 1. Okay, so they have drawn p. Let's just label it u or p. So what we should know, the inverse function is formed by reflecting our function in the line y equals x. So our axis of symmetry is our line y equals x. Okay, so here's my axis of symmetry, and this line is y equals x. That's how this graph is going to become the inverted function. Okay, so I've got that point over there. That's probably a mark. My graph is in the right shape. That's probably a mark. And the axis of symmetry is a mark. I need to draw the inverse function. Okay, now just remember this. The inverse function is a reflection in the line y equals x. And when you reflect in y equals x, you swap for your values, okay? So just random stuff. This is not the actual values, just random. Maybe this is like a -1. Let's make it like a -2. If this is -2 as a x, Okay, just random. If this is minus 2 as a x, then it's going to be like, let's say, bigger than 1. So let's say 2 as a y. So if I swap those around, so my random point that I said was minus 2 and 2. If I swap this around, then now my x value is supposed to be positive 2, so maybe that's over here, and y minus 2, so I think that's over here. So that value will be somewhere there. Okay, and then if I go on this side over here, maybe this is positive 2, maybe like a positive 2, and this is like a fraction, so maybe that's a half. So just random stuff that I'm coming up with just to see where the point would be. Okay, so that is going to be a half, would be probably somewhere here, and 2 somewhere there. And if it always goes through 0 and 1, it's obviously going to go through 1 and 0. Okay, I just did that so that I can have a nice idea of where my graph is going to exist. Okay, let me move that a bit. Okay, and I can see a nice point there where it touches, but they didn't ask us for that coordinate, but I guess we could probably find it if required. So this over here is p to the power of minus 1, the inverse of p. Okay, and there's all of my marks. I'll cut the video here and then we'll continue with the rest of it.